Hello, thank you for coming. I'm Adam. I'm a consultant with QA Systems. We're a company that specialize in improving and enhancing the safety and security of embedded software, specifically in the embedded space. So if you're developing C or C++ code and you've got certain standards you need to adhere to, then we're the people you need to come and see. The company has been around a long time. We celebrated our 25th birthday last year. It was formed in Germany by my boss, Andreas, and he had a desire to bring products to the industry to help make developers and testers' lives easier in their day-to-day work. Since its formation, the company has grown considerably. So as well as our German-based office, we have a development center in the UK, a development center in Vietnam. We've got a UK office, a US office, France, Italy, and resellers spread globally. We're continuing to grow, and in the last year, we've brought to the market our latest software offering, which is a static analysis product targeted at people trying to adhere to the MISRA C code set. So I'll put up some slides showing our existing customers. Maybe some of you are from these companies. If so, we'd really like to meet you in person. Come over to see us in Hall 4. Maybe some of these logos are those of your competitors, in which case you should definitely come and see us. Maybe they're your suppliers. Maybe they're just people that you admire. But I'm sure there's a logo on this screen that everyone recognizes, and that should encourage you to come and find out a little bit more about what we're doing. So this is specifically automotive. It makes up probably around half of our customer base. But we don't just target automotive. We've also got a range of customers in other industries. Anyone that's developing embedded products that need to be safe, secure, and reliable. So we've got people using our software to test everything from autopilot systems and missile defense systems through to industrial automation, things like controlling nuclear power plants. Actually, the first generation of the Nokia phones, the brick phones, all of the software on that device was tested with our products, which is why I like to think Nokia developed the reputation they did of being indestructible. So what are we here to talk about? We're looking at tools and how they can help the developer save time, money, and effort. But how do we do that? What do we mean? So traditionally, as a product kicks off, you go through a design phase. So you lay out the foundations for the work that you'll be doing throughout the course of the project. You then hit the coding phase, where you start to put kind of the sketch into something that's got a little bit more detail. And then traditionally, you hit the testing phases. So once you've got some code cut, you then move into various test scenarios. You think about how you're going to exercise that code, see if it performs as you'd expect, and see if it meets the requirements. Those testing phases increase in complexity as the project moves through its life cycle. And as we go through those testing phases, we're going to detect bugs. We're going to detect non-conformities with requirements. We're going to detect coding flaws. Maybe we're going to detect that we're not coding things according to the guidelines set down by the standards that we're trying to adhere to. As we pick up those bugs, the longer it is between the code being cut and the bug detected, the more cost it will imply the project has to bear. So if you find a bug towards the end of the project time span, winding right back and trying to fix that at the code level maybe the developers have moved on to another project, maybe they've forgotten how they coded their algorithm. Actually determining the root cause of that bug and solving the problem is going to be much more time consuming and cost a lot more to the project. So what we're trying to do is bring that defect detection as early as possible in the project. So trying to detect things at time zero. Test as much of the code as possible at the point it was written. And by doing that, we shift left. That's what everyone means by shifting left. We're basically exercising, testing, and really hammering out all the issues in the code as early and as quickly as possible. So I just spotted this, came up on one of my Facebook feeds the other day, and I thought it would be quite interesting to put on the screen. What we're trying to do with that shift left approach is reduce the technical debt that you're introducing into your project. Technical debt, kind of unknowns, kind of bits of mess that you've pushed to one side and you think you're going to deal with them later. Obviously, there's parallels to kind of engineering, building bridges, building houses. If you don't fix things early on, you end up with a house that looks like that, and then a confused management person coming along saying, why is it taking so long to add these new features? So just to reiterate what we're doing, we're reducing the cost of fixing these defects by finding them earlier. DevOps is one solution or one approach to try and solve this problem. So in the enterprise software space, DevOps is a buzzword that gets bounced around a lot. I'm starting to hear it a lot more in the embedded space. It's not just about tooling. It's about an entire methodology. So bringing more business functions closer to the coalface, closer to where the code is being cut, closer to where things are being tested, and trying to get interaction across the business as early as possible in the project lifecycle. So there's the kind of mentality that you need to tune into. There's also the process. So you need a well-defined process. You need everyone on board with that process, and you need buy-in. And the final piece in the puzzle is the tooling. You need the tools available to you to allow you to bring the entire company together and work on issues as they crop up. So you often hear of DevOps pipelines. What people mean there is having a chain of tooling in place so that as many stages in the process are automated and run without human interaction. So this DevOps process can help you shift left, but it's not the be-all or end-all. You shouldn't spend all your time building a perfect DevOps process and then forget that you're actually producing a product. So our approach on that is not to go full DevOps, not if it doesn't suit you. It needs to be a phased approach, an iterative approach, depending on the organization that you're applying it to. We've picked out a couple of major areas where we think we can improve people's DevOps pipelines and make it easier for people to get to grips with this way of thinking. So the first thing I'm going to talk about is the unit testing. Once you've got code produced, you want to create low-level unit tests for that code as soon as possible and have those tests checked into a regression test suite so you can run them as frequently as possible. We also have QA Misra, which is our static analysis tool for ensuring the code complies with industry standards. And again, you want that rule checking to take place automatically in the background and as frequently as possible. And then the final step is the kind of deep analysis, the things that the bug hunting static analysis tools will find. And here we've teamed up with a partner, Absint, who also in Hall 4. They've got a static analysis tool called ASTREE, which comprehensively scans your entire code base, looks at the syntax and semantics of that code, and can pull up all of the predicted defects that may take place. So between this trio, the rule checking, the early unit testing, and the deep sound static analysis, we can really automate and improve things early on and help you shift left. So traditional DevOps sits about here in a process flow. So you've got your developers down here cutting their code. They check in, hopefully quite regularly, these code changes to a centralized repository. And then your DevOps pipeline sits somewhere here. So it fetches the changes from your central repository, builds, tests, and reports on what it finds, and then feeds back to the developer. So that's a good approach. If we check in daily, we're going to get these reports back daily. We can quickly act on any findings that these tools come up with. But there's a piece missing, and that's tools for the developer desktop. And all of the products that we put into place have both a DevOps, CI, both a CI, server-based solution, but also a desktop solution. So if you're trying to write code that adheres to Misra, you want to know at the point you've written that line of code whether it's going to meet that criteria or not. You don't want to wait until the next day when you get the report back. So by running the analysis as soon as possible at this time 0, we get those results. And pairing up the two, we get the best of both worlds. We're doing checking and testing in 2 places, and we're going to get some real results there. So a bit deeper into the products that we've brought with us today. If you're interested in a deeper demo of either of these 2 tools, come and find us. We're like literally 2 minutes walk that way. We've got coffee on the stand, and we've also got a driving simulator to keep you busy if all of our engineers are busy doing demos. So on the static analysis side, we've got our QA Misra product, specifically looking to check compliance with the Misra guidelines. We also bring in some of the rules, some of the kind of more important rules from things like CWE and AutoZAR. And we're looking at the syntax of the code. So how the code looks, how you've formed it, how you've written it. What we're not doing, particularly with QA Misra, is doing this deep analysis, this deep simulation to find buffer overruns, memory leaks, and so on. That comes later in the piece. And then on the software testing side, we've got Cantata, which has been in the industry over 30 years now. It gives you an automated testing framework at the unit and integration level. It allows you to monitor for code coverage and generate reports on that code coverage so that you can submit the necessary evidence to your certification body. And it's nice to work with. Everything that we do is open formats. The test scripts that we write are written in actual C code or C++ code if you're testing C++. There's no intermediate scripting language you need to learn. We do have a UI that makes life easier for new users of the tool, but you're not bound to that. You can dive beneath the surface and interact with our products at ground zero, at the code level, where developers are most comfortable. So a little bit more about Cantata, our certified unit and integration testing tool. We're Eclipse-based, so it's going to look familiar to many developers. There's both the open source Eclipse version and various commercial vendors that have adopted Eclipse as their front end to their own compiler solutions. And Cantata comes as a deep set of plugins to Eclipse. So we take all of the burden away from generating and maintaining this test code, and also generate and maintain a build system behind the scenes that you can extract from the desktop, developer's desktop, and put into your CI server. We also work on host and target systems, whether you're running in a simulator or on real target devices. We can integrate with pretty much any C and C++ cross-compiler. So by default, Cantata ships with the host-based GCC compiler. It's very easy to pull that out and slot in whatever compiler it is you're using. The idea with the unit testing is to try and compile and link and run the code in as close to a production environment as possible. So that means using the compiler with the same options. It means ideally running on the same target that the final piece is going to run on. So with Cantata, we take a copy of your source files, combine it with our test script that we've automatically generated, pass it through to the compiler, and then download it to our target platform to run, and we get various results files coming back. So these range everything from a plain text log file to quite detailed coverage information and everything in between. The only requirement that we've got on the target system is that there's some bidirectional link so we can extract the results from the target machine back to the host machine. So that could be anything from a console window right through to scripting a debugger to pull the results out of an area of memory. We've got various out-of-the-box solutions for most common scenarios, and we've got a team of experts to customize that directly for your particular scenario. We've got a number of built-in configurations of this type, and we also allow you to edit the built-in configurations and customize it yourself. So what we're doing is, behind the scenes, parsing all the source file and creating kind of a detailed pre-process file. We're then running some algorithms over that pre-process file to figure out all the test vectors, the test paths through it. And from that, we can extract suitable test data without any user interaction that's going to generate high levels of coverage on your code. Once we've got these test cases, we can then combine it with the software under test, add in our coverage instrumentation, and pass everything through to the compiler to run. So we do a deep coverage analysis. I put this one on the screen because it's got a nice screenshot showing how user-friendly it is. So anything in green has been tested in this scenario. Anything in red has not yet been covered. And for those that are more technically astute, there's a deliberate bug in that code on the screen that explains why that line is in red and why it's dead code. So if you want to come over to me later and point out where the flaw in the code is, I'd be really interested to speak to you. Onto QA/MISRA. We do checks, compliance checks for coding standards, specifically QA/MISRA, but not just QA/MISRA. The selling point for QA/MISRA is it runs really, really fast. We're trying to get people to run these tools as frequently as possible. So I've got on my laptop, a open source GNU chess game, several thousand lines of code, and I can run a MISRA compliance check on that in a matter of seconds. So it's that kind of speed that you need to encourage people to run these tools as quickly as possible. High analysis speed, powerful graphical user interface to help you dive into the problems that you're finding. We can dive down to the code level and look at where those problems are. We've got plugins to Eclipse again, and also Jenkins on the CI side. And we've got a visual call graph to help you place the problems that we're finding in the call stack of the software that you're looking at. Again, all of the configuration and results for QA/MISRA are in open format, so it's very easy, very nice to work with, and you can integrate it with any number of complementary tools. And that brings me to another cartoon that popped up on my newsfeed recently. I thought that was quite relevant. I've definitely had that face when I've been looking at code for too long. So I'm sure lots of you can relate. OK, so that's where we sit. This is our verification-centric solution, which helps introduce DevOps methodology to the embedded safety-critical space. And again, we're over in Hall 4 at stand 227, if you would like to take a closer look. Thank you very much. So does anyone have any questions? I think we've got a few minutes. Yeah, sure. Yes, so the question was, does Cantata support Visual Studio Code? So we have integrations with Visual Studio compilers. We can pull out the Microsoft compiler and place it into our make files. Were you talking about VS Code or Visual Studio kind of full-blown suite? VS Code. So we're currently working on a coverage viewer for VS Code. It should be there in the next version in the next few months. But because Cantata works at the source code level, there's nothing to stop you opening up the Cantata test scripts in VS Code and working with the test data and the test framework directly in VS Code. So while our plugins are primarily Eclipse-based, you're not tied to that at all for working with the tests as they get generated. But we've got more for VS Code in the product roadmap. Any further questions? OK, that's great. Well, thanks for your time, and thanks for your attention.